All right, so lesson 6.5, we're going to be looking at point slope form today. So we just finished slope intercept, y equals mx plus b. That's still going to be involved here. In that equation, just by rearranging it in that certain way, you could see the slope and you could see the y-intercept in the equation. And so today we're going to look at an equation which can be equivalent to that, but when you arrange it in a certain form, you can actually see an actual point that's on the graph and the slope. And so if you're given that kind of information, you don't need to go through any extra steps or any other process. You can go straight to this particular equation if you have a point and you have a slope. So the big idea today, an equation for the line through any given point with any given slope can be determined with the slope-intercept form of the equation. So here is the point-slope form. Y minus y1 equals m, and then inside parentheses, x minus x1. Now, if you think back to the other one that we used, notice that it had a y and an x in it, and so does this. There's a y here, and there's an x here. And so even when we plugged in for slope and intercept, we still had the y and the x, and those are the values that you could actually plug into. Now, here we're going to do the same thing. We're going to keep the y and the x. We're not plugging into those right now, but we are going to plug in for slope, and we're going to plug in for x1 and y1. So where do they come from? So m, we know, is slope. So if we can get an equation in this form, our slope can be identified just as it could in the other equation we looked at. But now we've got these extra x1s and y1s, and that's a point. So there's a point on the graph, and that's going to go right here. So your x from your coordinate goes right there, and your y from your coordinate goes right here. Now, one thing I want you to notice is there's a minus in front of each, but those actually represent a positive x and a positive y. So it can be a little confusing at first because we're so used to seeing a minus and that means a negative. But in this particular equation, we want to see a minus. Okay, if we see a plus, that means this equation was changed. And it's changed because you plugged in a negative. And instead of writing minus a negative, it goes plus plus, and we just put plus. So we'll get to that in a second. But the actual equation has minus signs. So if you plug in positive numbers, they stay minus signs. The only times these will change to a plus is if you actually plug in a negative number, and minus a negative becomes plus. Okay, so let's jump right in and take a look. So example number 1, we're going to find an equation for a line with the given slope that also passes through the given ordered pair. So if we were given this and we said graph it, we would start at this point, and then we would use the slope down 2 over 1, down 2 over 1, and we could graph it. But now we want to just write the equation. So we can't use y equals mx plus b because while we do have slope, we don't have the intercept. Okay, we just have this random point on the graph that's also on this line. So now we're going to go to this new equation. Y minus y1 equals m x minus x1. So this equation allows us to plug all this in. And we're actually going to not just plug into this, but rearrange it and put it into this much more useful y equals mx plus b form. But we can get from here to here given this information. So step 1, write down the formula. All right, step 2 is going to be to substitute. So we're going to plug in for y1, m, and x1. The x and the y stay, just like when we plugged in for slope and intercept, the x and the y stay. So it's still going to say y. Now, this is my x1 and y1. That's my point right there. So if I'm plugging in for y, it's a 6. It's a positive 6, which doesn't change anything. When you plug in a positive, nothing changes. So it's still going to say minus 6. So again, take a look at that. When you plug in a positive number, it says minus because that's what the equation is supposed to say. That's what it starts as. So when you plug in a positive, there's no change. Slope is negative 2. And then in here, again, we're going to keep the regular x and y. So it's x minus x1. Now, x1 is a negative number. Instead of writing minus -8 and then going plus plus, which is not incorrect, we're just going to automatically go to plus plus and put plus 8. So it's important to see here, this is supposed to be a minus sign. And since it's a plus, I know that this 8 is actually a -8. So negatives will change the subtraction signs to a positive. Okay, once we've got it like this, step 3, simplify and solve for y, which puts it in y equals mx plus b form. Why is that so useful? Y equals mx plus b form. Super easy to graph, super easy to pull different information from. Okay, so we're always going to fall back to that y equals mx plus b form. So we got to get from here to here. So the first thing you're going to do is you're going to distribute. So we're going to get rid of these parentheses right here. So it's going to be negative 2x. And the negative times a positive is a negative. So I write minus 16. All right, I'm close here. If I want to get y by itself, I need to get rid of this minus 6 so I can get in my y equals mx plus b form. So I'm going to add 6, and I'm going to add 6. Notice where I placed it, directly underneath what it's going to interact with. I'm not going to put it under the x because a 6 and an x, you can't put them together. You can't do anything with it. So I put it right under the 16. So y equals negative 2x, and negative 16 plus 6 is negative 10. So I write minus 10. And so I've now written an equation that represents this line. So this original equation also represented the line. These are equivalent equations. And this one's useful because it gives me the slope and it also gives me a point on the line. And this one's useful because it gives me the slope and the y-intercept. So they're both useful in different situations. We need to make sure that we can plug into both depending on what information is given to us, and that we can go from here to here. We can transfer to the other equation. All right, so let's try the same thing here on letter B. Starting off with y minus y1, x minus x1. Plugging in now, so it's very easy to get confused and plug things in the wrong spots. So I think you should always label and just be careful and double check everything that you're doing. So we're going to plug in y1. It's a negative. When you plug in the negative, it becomes a plus here. So it's going to say y plus 4. So when you plug in a negative, you actually write plus. Slope just falls right in, 3. And in here, it's going to be x minus x1. Now, x is positive, so I'm going to put minus 6. So again, it's kind of like the opposite. You plug in a negative, you actually write plus. You plug in a positive, you actually write minus because that's what the equation starts as, and a positive isn't going to change it. Okay, let's distribute to simplify. So 3x and 3 times 6. Don't forget to multiply the 3 and the 6 is 18. So 3 times x is 3x. 3 times 6 is 18. And now all I have to do is get y by itself. So I'm going to minus 4. 3x stays. This is negative 22, so minus 22. Again, let's go back to these two equations. Think about why 3x has to still be there. It's not going to change because in slope-intercept form, right here is the slope. And in point-slope form, right here is the slope. And if these are equivalent and they represent the same line, the slope can't change. It's the same line. It's going to have the same slope. So the 3 has to match the 3. It can't become something else. If it becomes something else, we have a different slope. We have a different line. These equations represent the same line. They're just rearranged to give us different information. If we arrange it like this, we can see a point and a slope. If we arrange it like this, it shows us the intercept and the slope. All right, one more. But this one, we got the slope is 0. So let's see what happens. So starting with my equation, plugging in for y1. Remember, this is x1, y1. So I'm plugging in positive 15, so it says minus 15. Slope is 0. Let's throw that in for now. And then x minus x1, I'm plugging in a -6, so it actually goes plus 6. Now, when I distribute this, everything's going to be 0. 0 times anything is 0. So this whole side is actually just 0. And if I want to get y by itself, I'm going to add 15 to both sides. And y equals 15. Now, what do you notice about this? There's no x. There's no slope. Well, there is a slope. It's 0. So when you see this equation, y equals no slope and 15, the intercept's 15, so it's going to hit at 15, and there is a slope of 0. Okay, so that created the scenario where the x actually disappeared, so y equals 15. And we've looked at these types of equations and lines before. Y equals 15, so somewhere up here at 15, I've got this line, and it has a slope of 0. Think about what that looks like. Slope of 0 goes straight across. So this point right here, -615, is up here somewhere. And since the slope is 0, this line is always going to be at 15 on the y. So there, over here, there's a +6 and 15 somewhere on this line. And we write the equation of this line as y equals 15, because anywhere we go on this line, the y value is 15. The x changes, but the y does not. All right, let's flip it over. So example number 2, let's find the equation for a line with an x-intercept of 4 and a slope of 2. So your x-intercept, going back to the definition on the front, that's the point where on a graph where it crosses the x-axis. Okay, so the x-intercept, kind of like the y-intercept, but it's on the x-axis. You don't have to draw this every time. I just want to make sure we are understanding. So we have a line. This is your y-intercept that we find in y equals mx plus b. And this is your x-intercept, where your line hits the x-axis. Now your y-intercept, if you think about it, okay, the y value is going to be something. So let's say that this is 5. It's 0, 5, because this point right here, the x isn't left or right, it's 0. And the same is true here at the x-intercept. My y value is 0. So let's say that this is x being 5, but y, it's not up, it's not down, it's 0. Okay, so it's 5, 0. So anytime we have an x-intercept, we know the y value is 0. We've got this point. So if we go up to here, find the equation with an x-intercept of 4, so it's hitting the x-axis at 4. We know if x is 4 and it's on the x-axis, the y value is going to be 0. Every x-intercept has a y value of 0. When you're hitting this x-axis, the y value is 0. So this actually represents a point of 4, 0. So they've actually given you a point, and the slope is 2. So if we're going to plug this into an equation, we can use the y minus y1 equals mx minus x1 equation. So we're going to use 4, 0 as our point, and x-intercept is actually a point because the y value is 0. So y minus, remember, x1 and y1, so 0. Slope is 2, x minus 4. Now this 0 is going to just go away, so it's already in y equals form. We just need to distribute. So 2x minus, don't forget to multiply the 2, 8. Boom, nice and easy. So once we realize that an x-intercept of 4 is actually a point, 4, 0, it makes our life actually really easy, and we can plug into this point slope form. All right, example 3, how does this show up kind of in a word problem? So it says in 2006, population of Alaska was this. It was increasing by this per year. So we got to figure out what's the slope, and we got to figure out how do we use a point. Okay, so the slope is always the rate of change. So what is the rate of change? 7,800 people per year. Let's go ahead and put the label so we understand what we're doing. So that's what it's increasing by. Now what's the point? So if we're going to have a point, we need an x and a y. And this is going to be our x1 and our y1 when we plug in. So we're going to have two pieces of information that match each other. So in this case, the two things that match is the year 2006 and this number of 664,000. Okay, so in 2006, population of Alaska was 664,000. Okay, and then in 2007, we're going to have a different value. 2008, we're going to have a different value. So we can call this an ordered pair or a point. And so if we're going to write an equation, we'll fall right into this point slope form. And we're going to plug in this x1 and y1 and our slope. So our y is that 664,000. Our slope is 7,800. And our x1 is 2006. Okay, we need to kind of simplify this. So I'm going to leave this side alone for now. I'm going to distribute. So 7,800x minus. Then you got to multiply these two. Get this big number. You would use your calculator, of course. And now to get y by itself, we have to add this. So y is by itself. We still have the same slope. That hasn't changed. And then our final number here looks like this. Okay, so we got some really big numbers. So we can use this equation now to find out what the population is going to be in different years. So remember, x represented the year and y represented the population. So if we're going to plug in. Okay, so finishing up example number 3, we're going to use the equation that we built to answer the question, what will the population of Alaska be in 2009? So just checking back here, our x and our y represents our year and our population. So if we plug in the year 2009 for x, y will give us the population in that year using this equation that we built. So we're going to start with our equation. Okay, with the really big number. And we're going to plug in 2009 into our x. And all we're going to have to do is run the numbers, multiply, simplify. We'll have y equals something, and that's going to be the answer to the population in 2009. So all I'm going to do here is multiply, and then I will subtract to simplify this side completely. And just like that, I've got my answer. So I'm going to write this out in a sentence to answer the question. Population of Alaska in 2009 will be 687,400.